Hello everybody, I'm SnipeEye, Joshua. I wanted to record a quick tutorial showing how to assemble the Uno once you get it. It should arrive in a package just like this, either USB-A or USB-C. The assembly process is identical. I'm going to do it with USB-C because that's the only kind of port my laptop has. So it's got a little anti-static bag, and inside that bag you'll find the whole module. It doesn't require any soldering unless you want to use the rotary encoder. It also has a little bit of foam on these header pins. You can just take that off. If you want to test this right away, you can plug it in. I know this one works, so you'll notice that there's a couple of bridges between these two sections of the circuit board, and those bridges have small little drill holes along them, so they're designed to be just snapped right in half. So when you apply pressure, it should break along those, and we see they've both stuck to here. It can be a little bit challenging to get them off once you only have one, but either a set of pliers or end nippers like this should make short work of the rest of that FR4. As a note of caution, if you do sand it, try to make sure that you are wearing a respirator or doing it outside or both, because FR4 can be really bad for your lungs. Once you've disconnected those, you'll note this block of 8 pins and this receiving header, female header for 8 pins, and it just gets inserted like this. And that's basically the entire assembly. The only thing missing at this point is a switch. I've got a box navy here that I'm just going to show. There's a small little pin there and pin there, just a normal hot swap socket. And you can insert the switch into those. Now, hardware-wise, this Uno is ready to go. When we plug it in, I'll show you how to program this. So, when you plug it in, you'll see it lights up green, and you'll see a new drive mount on your computer. It's named RPi-RP2. First thing we need to do is install the firmware onto that drive. So if I open up that drive here, the firmware will be linked in a GitHub repository, and it's at firmware.uf2. So you just copy that directly over to the drive. If it will let me drag it, it's being dumb. There we go. It'll take just a second, and what this firmware.uf2 is a custom compiled version of CircuitPython specifically for this board. There we go. It's finished copying. You'll see that it's installed. The LED flashed 3 times, and the drive RPi-RP2 disconnected, and a new drive is mounted called CircuitPy. CircuitPy is great. We're going to delete all of the files that are on it, and we will go to the board directory. Again, that'll be linked in the GitHub repository, and just copy all of the files in there onto the drive. Onto the drive labeled CircuitPy specifically. This one takes a little bit longer. This pretends it's a flash drive. It's not really a flash drive, so it's doing a lot of stuff under the hood to move these files back and forth. So it's definitely going to be slower than a traditional flash drive, but it will work eventually. Just takes a second to copy things. The copy is now finished, and a minute after the copy finishes or so, just a few seconds really, you'll see this light up red if you're using the default key map, and that means everything's working properly. If I pull up a text editor here, then you can see when I press the button, it types the letter A, which is what it's mapped to right now. Now, this also is set up to accept commands from an infrared remote control. So in the default key map that I've provided in the GitHub repository, there are a few buttons from this specific remote control that are already mapped. However, most remote controls that you use are not already going to be configured because I didn't configure them because I don't have them. So I'll show you the process of mapping a button using some of the buttons on this remote control I haven't mapped already. So for instance, this kind of teal button down at the bottom here, green button, I haven't mapped anything to. So if you point it at that and press the button, you'll see it spits out a code. And this code is what it thinks that button is decoded as. And I've written a very generic handler, so this should work with almost any remote control that uses an infrared LED to communicate. There are some remote controls that are radio frequency, and this obviously won't work with that. But we can try another button like this pink one, and you'll see that's a slightly different code. So once you have the code of the button that you want to use, you can copy it, and we'll open up the main.py file, which contains the key map. I'll just do that in text edit here. And we go down to the IR handler map. And you see we just map the string here. And we can map it to whatever button we want, like volume down. And here I've got 4 layers set up, so I'm putting volume down 4 times, but you don't have to have multiple layers set up for this to work properly. And now I can save this, and when I next press this button, it will map it to volume down. So I'll go ahead and show that really quick just by saving this. When you save, since we're editing directly on this, it's going to reboot. Now that it's finished rebooting, I can press this, and it does in fact perform the volume down function. So mapping a new button is as easy as figuring out what the command is. It'll spit that out, copying that, and mapping it to a function. So that's the Uno. A couple of notes: the infrared demodulator is right here. It's this kind of black looking bubbly plastic component on the corner, and it should work pretty well. Infrared tends to bounce around a lot, but if you're having issues, try pointing directly at that, and that might help it receive better. Additionally, it's no soldering required if you want to just use a switch. However, if you want to use a rotary encoder, you'll solder it into these 3 at the top and these 2 at the bottom. And then a lot of rotary encoders have these kind of mechanical pins for mounting stability, and due to constraints on the circuit board, I only had the option to open up the hole for one of those mechanical pins. The other one you'll have to bend out of the way or chop off, but it won't obviously fit through that tiny little hole there. This can be removed at any time, and it's even interchangeable between the USB-A version and the USB-C version. So if you solder a rotary encoder to one, you can take that module and plug it into the other one, and it'll work just fine. And if there are any questions, please feel free to reach out via email or take a look at the KMK documentation. That's the firmware that this is running, and I think that should help clear up a lot of questions. Thank you so much for your support. Really appreciate it, and I look forward to seeing what you do with these.